right, so nobody is in the frame but me. Biorhythms. Okay, so in the Latin, you have circa, circadian, circa and dies. Circa meaning about or around, like circumference in math, and a day. So a circadian rhythm is about a day's cycle, a diurnal, day and night, 24-hour cycle. The sleep-wake cycle is one of them. And what's kind of interesting is that this is all about light, sunlight in particular. When the sun rises, which doesn't really rise, right? The earth just rolls to face it, rolls away. Now we have this second type, ultradian rhythms, from the Latin ultra, meaning beyond or above, and dies, day. This gets slightly complicated. It's more theoretical, yes? Come again? It probably, I can put all this stuff in Google Classroom. I just haven't figured out how to do it yet. But yes, I will try. Ultra dies. Okay, so it's beyond or above a day, and yet it means that it takes more than once a day. It takes longer, it happens in a shorter period of time than a day. So it's beyond or above a day, but it happens in less time. So the reason why is that what this is talking about is frequency. Does anybody remember the word frequency from physics? Like say the hertz, the measurement hertz, or on a radio, when you're tuning on a radio to different frequencies. Okay, so the idea there is frequency is about how often something happens per second. That's what a measurement of hertz is. If it's 3 hertz, it happens 3 times a second, which is probably more like that. If it's 1 hertz, it only happens once a second, okay? So the idea of this ultradian rhythm happening more than a day is that its frequency is higher than a day, which means its duration is shorter. So an ultradian rhythm, shorter than a day, can be something like the sleep cycles that we experience. So that could be like REM sleep, into deep sleep, back up to light sleep. Those cycles happen about 45 minutes to an hour. So those are less than a day. Those are ultradian rhythms. Next slide, please. Infradian rhythms. I don't know how to pronounce that one correctly. That's also from the Latin. Infra meaning lower in dies days. So this is a lower frequency than a day. So that means it's shorter or longer than a day. If it's happening less frequently than a day. I know you want to say shorter. The answer is longer. So something that happens frequently, it's happening at a certain pace. If it's happening less frequency, lower frequency, it's happening over the course of longer amounts of time. So in this case, it is once a month or once a season. Some of the rhythms, the biorhythms that they identify in the book, among humans, they include the menstrual cycle, roughly monthly. And among animals, examples are like hibernation. So that happens once a year, and it happens over the course of many months. It's a slow annual process, right? Probably leave it here for a second, just go back one. Just let people copy. And again, with any note taking, you don't have to copy every word. You can always just kind of get the general ideas. Okay. All right, move on. Sleep and sleep deficit. All right, sleep deficit. We have done a good job, I think, up to this point of talking about how important sleep is, right? We saw Bill Dement talk about drowsiness is red alert. If you are feeling drowsy and you are in a hazardous situation, get out of the hazardous situation. Drowsy driving is one of the most dangerous things on the road. This book also really emphasizes how dangerous sleep is in a biological way. A sleep deficit decreases the hormones that allow for the immune system to function. So if you were running on low sleep and then you go into a crowded scene and people are coughing and you have some interactions, you'll be much more likely to get sick. I can tell you from personal experience, that's definitely happened, where I feel like walking into a big public event and I'm not being well rested probably contributed to me getting like a cold or whatever after. Also, your sleep deficit increases the stress hormone cortisol. And here I want to write a word up for you all. Let's see right here. I'll do it in orange actually, because that is our class color for now. I don't want to change it. so I'll take this out initially. The word is dysregulation, D-Y-S, regulation. I'm going to break it apart into its word roots, which is dys. Dys is Greek, and it means bad. Regulation you might be familiar with. To regulate something is to make sure that its comings and goings are even. Your body has all sorts of regulatory processes. Certain chemicals come, your body enjoys them, and then it lets it process out. Cortisol is one of them. Cortisol is your stress hormone. It's what wakes you up in the morning. It's what makes you alert when something dangerous happens. When you hear a certain sound, snap, crackle, whatever. Your body then has to process the cortisol out. If you don't have enough sleep, the cortisol coming and going can be dysregulated. So instead of it coming and naturally going, you can basically have an elevated baseline. You can have more cortisol all day long, and it can keep you in a straight state of stress. Heart rate can go higher, and you can have a harder time focusing, and it's just difficult. Emotions get more raw. This can also impact learning and memory, yes?
So for dysregulation, is that for like everything? Like if you mess with everything, or is it just for a specific group?
Dysregulation is a very good word. It's not unregulated. So regulated versus unregulated is there are rules, there are systems in place. Unregulated, there's no regulation, there's no control. Dysregulated is in between. Dysregulated is there's still some type of a system, but instead of it working nice and regularly, it's now like kind of messed up.
That's for the whole body?
That's the whole body. The whole body has all sorts of regulatory processes that can be dysregulated. So it's just a very good word for this field, because sometimes when people have psychological symptoms of all types, it's not an underlying permanent condition. They're just temporarily dysregulated. A good example is substance use. So you have certain substances, you can have all sorts of these highly intense cognitive and mental experiences, and then it goes away. It wasn't that you were permanently turned into a person with a condition, it's that temporarily, whatever regulated system that allows you to have clearer perception was altered, an altered state of consciousness. We'll get to that soon. We're going to talk about psychedelics next. Yes, sleep deficit is also associated with increased rates of obesity, hypertension. It suppresses cancer-fighting immune cells, premature aging. It's bad. Sleep will make you well, and sleep deficit will add up and make you unwell. We talk about driver fatigue, drowsy driving. It's more dangerous than alcohol use. And at the very bottom, what you can't see, is it says most teens need 9 hours of sleep a night. Can we go to the next slide? Most teens need 9 hours of sleep a night. Get your sleep. 9 hours. And if you're not getting 9 hours, I'm not doing my job. I try hard. All right, next one. Mechanisms of sleep. So there is a brain structure called the hypothalamus. We'll learn about this later. The hypothalamus. I should know the Greek on that too. The hypothalamus perceives changes in your circadian rhythm, right? It perceives changes in the light and the dark. So when light hits the retinas on the back of the eye, they send a signal to the hypothalamus. Gone. It's time to wake up. When it gets dark outside, your body goes, hey, there's no more light anymore. Melatonin starts kicking in, time to go to sleep. Okay? Hormone melatonin helps to regulate sleep. The blue wavelength of light is the one that has the most dramatic impact on melatonin. You'll see sometimes people have orange blockers, like orange shaded glasses at night, because they're looking at computer screens and they don't want to get that fatigue. They want their body to produce a natural amount of melatonin so they feel chill rather than wired, If you are on your phone and it's right in front of your face, when you're in bed trying to go to sleep and you can't, it's probably that. It's probably that light right in your eyes. And when you wake up, you want to wake up and you want to look at the sunlight. That's going to be a part of a good, healthy way to regulate your body. So let's go to the next slide. And this one, maybe it'll work. If you can move the mouse around, you might be able just to click right on it. Yeah. Just try to click. All right. I'm not hearing sound.
I wake up in the morning.
Oh, there we go.
I want to read phone. But I know that even if I were to crank up the brightness on that phone screen.
I'm going to pause just to introduce who this is. Oh, wait. Did I do that?
I wake up in the morning and...
Okay. So this is Andrew Huberman. He's a neuroscientist. Well, actually, he's an optician. He is a neuroscientist. He studies the brain, but he studies the optic nerve. That's his published academic research. He does have a lab at Stanford. It doesn't really do a lot, but he also became quite the popular podcaster. And it happened right after that whole era in the COVID when people were passing around a lot of non-medically sound suggestions. He kind of came right after that. So the one thing I can say about Mr. Uberman is he is very good about his science. He always cites his sources. He always has peer-reviewed sources. So I feel comfortable recommending it to a classroom of students because he's always grounded in his rigorous academic research. But in this case, he's talking specifically about sunlight in the morning and kind of what works best for your body. So yesterday and the last week, we were talking about, I was trying to encourage you for sleep hygiene to improve your sleep. This is kind of the next step, which is when you do want to wake up, what's the right way to wake up? That will give your body the best amount of energy for the day. Thank you.
I want to reach for my phone, but I know that even if I were to crank up the brightness on that phone screen, it's not bright enough to trigger that cortisol spike and for me to be at my most alert and focused throughout the day and to optimize my sleep at night. So what I do is I get out of bed and I go outside, and if it's a bright, clear day and the sun is low in the sky or the sun is starting to get overhead, what we call low solar angle, then I know I'm getting outside at the right time. If there's cloud cover and I can't see the sun, I also know I'm doing a good thing because it turns out, especially on cloudy days, you want to get outside and get as much light energy or photons in your eyes. But let's say it's a very clear day and I can see where the sun is. I do not need to stare directly into the sun. If it's very low in the sky, I might do that because it's not going to be very painful to my eyes. However, if the sun is a little bit brighter and a little bit higher in the sky, sometimes it can be painful to look at. So the way to get this sunlight viewing early in the day is to look toward the sun. If it's too bright to look at directly, well then don't do that. You just look toward it but not directly at it. It's absolutely fine to blink. In fact, I encourage you to blink whenever you feel the impulse to blink. Never look at any light, sunlight or otherwise, that's so bright that it's painful to look at because you can damage your eyes. But for this morning sunlight viewing, it's best to not wear sunglasses. That's right, to not wear sunglasses, at least for this morning sunlight viewing. It is absolutely fine to wear eyeglasses or contact lenses, so-called corrective lenses. In fact, those will serve you well in this practice or this tool because they will focus the light onto your neural retina and onto those melanopsin and intrinsically photosensitive ganglion cells. If your eyeglasses or contact lenses have UV protection, that's okay. There's so many different wavelengths of light coming from the sun, and they are bright enough that they will trigger the mechanisms that you want triggered at this early time of day. So try and get outside, ideally within the first 5 minutes of waking, or maybe it's 15 minutes, but certainly within the first hour after waking. I want to share with you 3 critical things about this tool of morning sunlight view. First of all, this is not some woo biology thing. This is grounded in the core of our physiology. There are literally hundreds, if not thousands, of quality peer-reviewed papers showing that light viewing early in the day is the most powerful stimulus for wakefulness throughout the day, and it has a powerful positive impact on your ability to fall and stay asleep at night. So this is really the foundational power tool for ensuring a great night's sleep and for feeling more awake during the day. Second of all, if you wake up before the sun is out, you can and probably should flip on artificial lights in your internal home environment or apartment or wherever you happen to live if your goal is to be awake. Right? If you wake up at 4 in the morning and you need to be awake, well then turn on artificial lights. Once the sun is out, however, once the sun has risen, then you still want to get outside and view sunlight. Some of you will wake up before the sun comes out, and if you're asking whether or not turning on artificial lights can replace sunlight at those hours, unfortunately the answer is no. Unless you have a very special light, we'll talk about what kind of light. The bright artificial lights in your home environment are not, I repeat, are not going to be sufficiently bright to turn on the cortisol mechanism and the other wake-up mechanisms that you need early in the day. The diabolical twist, however, is that those lights in your home or apartment or even on your phone are bright enough to disrupt your sleep if you look at them too late at night or in the middle of the night. So there's this asymmetry in our retinal, our eye biology, and in our brain's biology, whereby early in the day, right around waking, you need a lot of light, a lot of photons, a lot of light energy. And artificial lights generally just won't accomplish what you need them to accomplish. But at night, even a little bit of artificial light can really mess up your so-called circadian, your 24-hour clocks, and all these mechanisms that we're talking about. So if you wake up before the sun is out and it's still dark, please turn on as many bright artificial lights as you possibly can or need, but then get outside once the sun is out. On cloudy days, you especially need to get outside. I repeat, on cloudy days, overcast days, you especially need to get outside and get sunlight. You just need to get more of it. Now, how much light and how much light viewing do you need? This is going to vary depending on person and place, literally where you live on Earth, whether or not there's a lot of tree cover, whether or not you're somebody who has sensitive eyes or less sensitive eyes. It's really impossible for me to give an absolute prescriptive, but we can give some general guidelines. In general, on a clear day, meaning no cloud cover or minimal cloud cover, you want to get this sunlight exposure to your eyes for about 5 minutes or so. Could be 3 minutes one day, could be 7 minutes the next day, about 5 minutes. On a day where there's cloud cover, so the sun is just peeking through the clouds or it's more dense cloud cover, you want to get about 10 minutes of sunlight exposure to your eyes early in the day. And on days that are really densely overcast or maybe even a rainy, you're going to want to get as much as 20 or 30 minutes of sunlight exposure. Another key thing is do not forget about, just don't try and get this sunlight exposure through a windshield of a car or a window, whether or not it's tinted or otherwise. It takes far too long. It's simply not going to trigger the relevant mechanisms. You would be standing there all day trying to get enough light into your eyes from the morning sunlight, and by then, the sun will have already moved from low solar angle to overhead, and it simply won't work for all sorts of mechanisms related to your circadian rhythm functions. So just don't try and do it through a windshield, sunglasses, or a window. It's just not going to work. Get outside. If the weather is really bad, or for whatever reason, safety reasons, you cannot get outside, well then I suppose try and get near a window. That would be the last resort. But you really want to get outside to get the sunlight exposure.
All right, thank you, Mr. Huberman. So his 3 points I've summarized here. Light viewing is a foundational tool of wakefulness. So light is what wakes you up. Artificial light cannot replace that in the morning, but in the evening, it can disrupt your sleep. So we've all known that experience, I think, what we talked about at least once before. It's the middle of the night, you go to the restroom or something, you come back and you check your phone. Maybe you're on your phone a little bit, maybe you instinctively go to Instagram. Next thing you know, you can't go back to sleep because the phone has disrupted your night process. He does say at the end here, 3 kind of like general time windows for what, how to get the most benefit out of the sunlight. Do you remember the first one? It's a sunny day. How much time do you need? Yes?
5 minutes.
About 5 minutes. And how about the second? When it's like a little cloudy? 10 minutes. And when it's very cloudy and very, very dim outside, 20 or even 30, he says. So, I'm glad that most of this class indicated on the survey they're not taking a lot of caffeine. There's no need, no rush, you're all young. A lot of adults would do this. This would be our coffee time. We'd walk out and have a cup of joe or something in the sunlight. But for all of you, I would encourage you, if you have a favorite song you want to start the day with and really set the mood, if you just want to be out there and meditate, mindfulness, this is a great excuse, Say, hey, I just got to be outside for about 5 minutes. Just let, again, that low angled sunlight, so it's not middle of the day, it's right when that sun's kind of coming up and you're getting ready for school. That would be the time to just let some of that light in. And he's always talking about it's got to be on the eyes, it's got to hit the retinas for it to activate the brain that way. May I ask again for your assistance on the presentation? Thank you. So we'll go to the next slide. Okay. So this is your sleep cycle, generally speaking. It can certainly be disrupted, but this is generally the pattern that it follows. Your first cycle drops you all the way down, and you're out. Deep sleep. Non-REM sleep, NREM, NREM, stage 4. Very unresponsive, hard to rouse, you're out. Also, this is a very important phase of sleep. This is where a lot of restoration comes. If this gets interrupted and you only ever float around up here, you end up waking up even after hours and hours of sleep and you don't feel rested. So a lot of good happens down here. You tend to plummet down, you bounce back up, go down again, up. See this kind of ultradium rhythm here? Happens more than a day, right? Next slide, please. Here's an example from my Fitbit last Friday. Follows the right pattern, went down, roughly we would stay down here a little bit, maybe a little rise. Back up, back down, a little bit. Nice and consistent. Only thing that was a bummer last Friday is I woke up at this time and I couldn't go back to sleep because I was thinking about this class and other classes and all the work to do. So just know your teacher is putting in the hours. Can we go to the next slide? This was last night. Not great. Next slide. Okay, so why do we dream? These are the 4 general ideas of why we're dreaming. Remember I pointed those out and said, hey, read that section on your sleep journal, indicate when you see a dream what you think is going on. Do you think that it's information processing or a physiological function? Maybe it's the activation, synthesis, or the cognitive development. So we'll go through each of these. Information processing. This is essentially the notion that we're all little computers. Our brains are little computers. They take in all sorts of inputs. Although remember from that first video I showed you, what percentage of information out there in the world do we actually take in our perception? Do we remember? Of 100% of information that's out there in the world, visual, auditory information, how much actually makes it through into our brain? Remember, it's like a thumbnail held at arm's length. Remember, anybody? A percentage? You can even guess at this point, I'd be happy with that. 30, even less. 1%. So 1% of the visual information in the world is coming through a very narrow aperture, very narrow window. It's going into our brain. And it's not because we only see a little detail, it's because we see a lot, but our brain throws all this information out because it figures it doesn't need to study everything. And the statistic from that video was, you may remember this, how much bigger would our brain have to be if it processed all of the information it received? Very big, 600 times bigger. That's one big noggin. You'd be rolling around with a wheelbarrow. Okay, so the idea of the information processing is that our REM sleep, which is when we're dreaming, is facilitating the storage of memory. So it's taking all the random stuff that we saw in the day and it's sort of chunking it and moving it around and deciding what's important and what associates with what, and it's storing it like a computer, very efficiently putting it where it needs to go. The reason that they say there's some proof here is because when we go through an increased stress experience, we tend to have an increased REM stage. So can we talk about that? When we go through an increased period of stress, why does our brain remember more? And I'd encourage you to think back to your biology class in evolutionary biology. Why would it be in the benefit of an organism to remember more when something dangerous happened to it? When a stressful experience happened? Yes, we got 2 hands, but you first.
So it doesn't happen again?
So it doesn't happen again? Yeah, it's basically that. It's like you've just gone through something that was harrowing, very stressful. Your brain's like, well, tell me everything, because I don't want to do this again, right? Now this is, let's think, we'll probably talk about these subjects further on in the class. This is why trauma is difficult, because when people go through a traumatic experience, it tends to be a physically stressful experience. Their brain remembers a lot, remembers every detail, because that was the way that our minds are set up to protect us. But then later in life, when you're trying to overcome these traumas, you have a lot of memory associated with it, right? So it's difficult. And also it's a bit of our negative bias. So it's so hard for us to remember positive experiences. We have to kind of be reminded of them, or we have to think about them. They happen all the time. People are nice to us, we're cool to somebody else, we have a good feeling, somebody says something nice, but we don't really focus on them. But somebody says something rude to you, mean to you, you feel embarrassed, you have a cringe moment in your life, all of a sudden you can remember that, right? So that's part of that positive and negative bias that we have. Next slide. Physiological function here. Honestly, I was not too clear on this one myself. The text essentially said that because babies have longer REM sleeps, maybe REM produces the growth hormone and interaction with the pituitary gland, and I just didn't find that to be very convincing. So I would want to look at the research on that or learn more about that myself. But if you're interested in it, I strongly encourage. The activation synthesis, I like this one a lot. This one's very interesting. It's almost like hallucination, which we'll be talking about soon. The idea that you're sleeping, your brain's going through some process, and part of that process is that there are random firings of neurons. So your brain is getting like random signals, and it's going, wait, I'm a pattern-seeking organ. I can make sense of this. So even though it is random, your brain goes, no, there's a story here. Let me make it up real quick. And maybe that's why in your dreams, you're walking along with a friend, and the next thing you know, you're both on a boat. Or all of a sudden you turn a corner and you're in a forest. Like, how does that make sense, right? Why does your brain do that? It could be because of this. Random neural activity is being interpreted by a pattern-seeking mind to tell a story. The last is cognitive development. It's just the idea that as your brain is evolving, these are ways in which it's evolving. It's just becoming a dreaming organ. And it's a reflection of what we know or understand. So the claim in the text was, if you don't know about something, if you've never seen it before, you can't possibly dream about it. And I wonder if that's true, because I have a feeling there's at least one person out there who's dreamt of something they've never seen before. All right, sleep disorders. So there's a bunch here. We've got insomnia, which you may have heard about. It's people who have a hard time going to sleep or remaining asleep. And sleep apnea. Sleep apnea is pretty common amongst my age group and a lot of people in America because of the obesity epidemic. So it's when the airway is obstructed and the snoring that gets really heavy actually turns into kind of a choking. And then the person reacts by coming out of it, and wakes up. And so their sleep, instead of having this nice cycle to it, is just interrupted with constant waking up. Yeah, I'll let everybody copy. Narcolepsy. I like the term here, the sleep attack. So it's the idea that you've just gone through, say, like a shock, some sort of high energy, high alert, arousal it's called in scientific terms. The nervous system is aroused, often from emotion, and then your body has this response where you get really just sleepy and you just pass out, you lose consciousness. It's a rare condition, they love to study it. Somnambulism, this is another classic Latin moment for y'all. Somnambulism. Have you ever heard of ambulatory care in a hospital? Or maybe going out for a perambulation? It's going out for a walk. So ambulare in Latin means to walk. So somnambulism means to sleepwalk. Night terrors, these are different than nightmares. Night terrors are going to be much more intense and the person tends not to remember them. So it's almost like sleepwalking. We have bruxism. This is grinding of the teeth. So a person's completely asleep and it sounds like you're rubbing bricks together. They're grinding the teeth. So they usually treat that by putting in a mouth guard and let the person, not damage their teeth. Bruxism also is a symptom of certain substance abuse. Like when you're using certain substances, you're overwhelming the brain, dysregulating again with dopamine, and that's one of the motor symptoms as people will grind their teeth. Emeresis is just urination, unplanned, uncontrolled urination at night. The text talks about it as bedwetting. I'm not really keen on that term because it's something we think about with children and so on. This is just a medical condition for some people who have it. There's no reason to associate it with childhood versus adulthood and so on. Myoclonus, sudden jerking of body part. I'm not 100% familiar with this, but I have heard of what's called restless leg syndrome, where people are in bed and they're just shaking around and it doesn't affect their sleep so much, but it definitely affects the person next to them. So, all right, I think that's the end of that presentation. I'll leave this up though while people are working. Appreciate your help. Thank you, sir. And 2, 4, 6. Noah, if you could pass this back, thank you. 4, 5. Carmelo, appreciate you. 3, 5, 6. There we are. 4, 5. Dominic. 2. Yes. Oh yeah, by all means. All right, well, so I've got, we're missing a few copies for that row, but what I would say is, we're gonna be working in groups anyway, so it shouldn't be too bad. So for this assignment, this is just kind of like a light group social learning activity. I would say your free form groups, really what we want, there's about 4 categories here of each sleep cycle. Sleep stage 1, stage 2, 3 and 4, and 5. So if you can, form groups, pick a stage, do some reading, and then I want you to share out to the class as a whole when it's done. And rather than just read the text, kind of share in your own language. Like, just speak the way you understand what that sleep cycle is. And did I have a hand somewhere over here? No? Okay. All right. So thank you. We'll do that for about, 5-10 minutes or so. And I will put on music. Hope that works.